I guess y'all read my cow horns will hook. Did everybody read that? I have people. Somebody tell me how many sections of homework we have in chapter 3.
11.
I had people starting doing the chapter 3 homework yesterday. Yeah, I went and looked at some of the people that were emailing me and telling me that they didn't know and telling me that they thought it was due today at noon. They thought the dog ate their homework and okay, 11 sections of homework and you start on it on Monday or Tuesday. I'm sorry. I don't have anything to say to that. Okay, I really don't. And then you want to send me an email or a text message that asks me to extend it? No. Now, Mr. Michelle will tell everybody in here. Anybody else? Who else has had me besides Mr. Michelle? Anybody? Mr. Michelle, do I give second chances as far as homework and tests?
Definitely
yes or no?
not. Definitely
yeah,
not.
I do. I'd give,
Oh, yeah, for homework, yes.
Yeah. At the end of the semester, I give a reprieve, okay? And I don't care how many homeworks you've done. I don't care how many, but I'm not going to extend the homework and try to let you do 11 sections of homework in 24 hours. Now, I'm only talking to about half the class, okay? There's 26 people in the class, and about 9 or 10 of y'all have done the test, have done the homework, and there's not a problem. Might even be 12 of y'all. I can't remember. But there's some of y'all that I just don't understand the concept of doing 11 sections of homework in a couple of days. I don't understand that. So I'm not going to extend it. So don't ask. I don't care if your car blew up. I don't care if you got 6 dead grandmothers. That's not my problem. You not doing the homework the last 2.5 weeks is the problem. I'm done. Those of you that need to focus on something, you need to focus on doing the test tonight, by tonight, midnight, because 80% of your grade is test grades. So forget about the homework, that's done. And hopefully you can have a chance to do that later. I don't know. But I'm just amazed. I really am. I don't know. You know, I kid about the Tide Pods, but I really think there's some of y'all out there that's actually eating the damn things. And it's not just this class, the other class. There was 9 or 10 in there. Somebody explain that to me. Somebody.
Just immaturity.
I mean, I could understand 2 or 3 sections. I could understand Mr. Paris being lazy and not doing 2 or 3 sections. I can understand that. And I can understand Miss Levy being, you know, not understanding 2 or 3 sections and not having those done. I can understand that. I'm not talking to y'all. 11 sections. 0, 0, 0. Nothing. Nada. I just don't understand it. Okay. I'm sorry. And this poor guy just called me from my Math 110 online, and he says, I just blew him out of the water. I just blew him out of the water. I told him, I said, don't talk to me right now. I said, call me back later or email me back. I said, don't talk to me right now. Anyway, I just don't understand it, folks. All right, today we're starting integration. You have just went through the first half of calculus. The first half of calculus is derivatives. The second half of calculus is the opposite of derivative, which is called the antiderivative. Read the comic strip. Word problems, nothing but word problems. Thank you. Farmer Bob's vegetable garden is 20 feet wide by 30 feet long. Calculate its area in square footage. Okay, you got a rectangle that's 20 by 30. Let's put that in the first quadrant since distance is not negative. We'll put that in the first quadrant, and f of x is equal to 20, which means y is equal to 20. That's a straight line from 0 to 30. And take the antiderivative of 20, which would be 20x, and evaluate 20x at 30 and 0, and you get 600 feet, or 600 square feet. What have you just done with integration? What's his name on Foxtrot? Jason. What is he just completed with integration, or the antiderivative?
He's found the area of the square.
Area. And that is your objective with the antiderivative. Okay? That is your objective with the antiderivative. The antiderivative, or integration, the process of integration, gives you the antiderivative. All right? The antiderivative is the product. The integration is the process. So write this down, because Mr. Dosher got his camera fixed. Way to go, Mr. Dosher. See, that's trying. People are trying.
Yeah, you kept yelling at me for not having my camera on, so I went to my laptop.
Did you do 11 sections of homework in 24 hours, Mr. Dosher?
Well, I did most of them.
Oh. I think let's just wait and do it this afternoon. Yeah, we'll just do 11 sections of homework this afternoon. Anyway, now, when we did derivatives, I told you that you take the difference quotient and you put the limit theory with it, and you can find the equation for the tangent line. Okay? Here, we're going to take the area that you learned back in geometry, the length times the width, the base times the height, and we're going to add it to the limit as far as the base of each rectangle, getting smaller and smaller, like the width of a hair, and that is integration. Okay, so the first part of calculus is derivatives. That's why you spent 11 sections on the derivative. The second part is the antiderivative. The derivative gives you the equation for the tangent line. The antiderivative, or integration, gives you the what? The area under a curve. Okay? Everybody with me? Now, the algebra, the old algebra way, and you put it with the limit theory, is called Riemann's sum. Riemann's sum. Riemann believed that you could take any curve. I'm not going to go through Riemann. Now, let me also tell you this right now. Today is the introduction. I do not want anybody doing any homework. No homework for chapter 5 right now, okay? Because I've got to fix it. Do not do any homework for chapter 5 because I've got to go in and fix it because I'm going to cut some stuff out. Everybody with me? Okay. Do not do any homework for chapter 5 because right after class, I'm going to go in and turn it off. All right? So don't do any homework for chapter 5 right now. Those of you that took the test and did your homework the way you were supposed to do it, y'all have the night off. Okay? All right. Riemann believed that you could take any curve and you could break it up into boxes, and you could take the midpoint of that box, the midpoint right here between those 2 points, and you could multiply it times the height of the base times that height, and you could do that with every single box and add them all together, and that would be the area of the curve. But what if you were to apply the limit theory and make those boxes smaller? Now, I want you to look at this picture, and it's supposed to do nonstop, okay? There's 2 things happening here. Now, I'm going to turn it off when it gets, okay. Does everybody see those rectangles there? You see how big they are? This area right here I'm pointing at, that orange area and this purple area, what do you call that? If you're measuring the area under the curve, what would you call that?
Negative space?
Well, I was thinking more of excess. Wouldn't be excess? Because you're measuring the area under the curve, right? So wouldn't this outside the curve be excess or error? Yes or no?
Yes.
What about
Yes.
down here? You got this orange area here or whatever, and you got this blue area. That's excess or error. And then you got these 2 blue areas right here. Is that error or excess? Excess? Yes. So is this very accurate?
No.
Yes or no?
No.
So what happens if we use calculus and the infinite law to make those boxes, instead of 3 inches wide, let's make those boxes smaller until we get them the width of a hair. Somebody tell me what's happening to the error or the excess.
The rectangles are starting to
going
fit to the
away.
curve better.
And the excess or the error is what?
Lesser.
Decreasing. Everybody look at it. I'm gonna leave it up there. Because no matter what, and Riemann's, you see Riemann's black line over here. There's Riemann's line right there. Instead of measuring the height here, he said, do the midpoint. Now, I'm not going to go through Riemann because that's why I'm going to fix the homework. I'm not going to go through Riemann because I've shown you how calculus can take the place of algebra plus the limit theory. I've shown you that with the derivative. I'm not going to do that here. I'm not going to make you work extra hard to show you that same point here. All right? So, but as you can see, there's Riemann. Riemann says that you need to use that middle line to multiply by the base. Now, when you do measure something under a curve, let me draw a curve. Well, I had a brand new, there it is. There's your curve. The width of that box is called what? dx. Write that down. It's very important. The width of that box is called dx. The height of the box is equal to the what? The function. So whenever we do an antiderivative, the antiderivative from 0 to 10 of f of x dx. This, somebody tell me what f of x is. I just told you. It's the what? It's the height. And somebody tell me what dx is.
The width.
The width.
Which is called the
The width.
base. It depends on which formula you're using. Yes, base or width. And I'm multiplying here. And this is your basic setup for an antiderivative. Now, the limit theory basically says that your dx will get down to the width of a hair or less. Now, I use width of a hair to make you as a student think about out of the box, okay? Where y'all saw these, what's happening to those boxes?
They're getting thinner.
They're getting
Getting
thinner
smaller.
and thinner and thinner to where they're about the width of a hair. And that's what you need to be thinking about. I could turn this one on also. There we go. Turn that one off. I already got the other one on. And you see that those rectangles that are going down here, dx is getting smaller and smaller by the limit theory. So when I talk about dx, I'm talking about dx being the width of a hair. dx is always included in the antiderivative. Write that down. dx is always included with the antiderivative. Always. Okay? Now, what is our goal in chapter 5 and 6? Get your outlines out and highlight 5.2 through 5.5 and 6.2. And that's why I've got to adjust the homework, so I do not want you doing homework tonight. 5.2 through 5.5 and 6.1. To me, out of all this, out of these two units, that's the two most important parts. We're looking toward this. You're going to be doing some of this in chapter 5. If I can find it, hold on a minute. You know, finding the area under a curve. And I don't know why it's going so slow. Not supposed to be going that slow. Wow.
Huber, quick question.
Yeah.
On the syllabus, it also has us doing chapter 4. Do we need to worry about that now, or is that further down the road?
We just skipped that. We skipped chapter 4.
We're skipping that? Okay, I just wanted to make
Yeah.
sure because I just saw it on the
I thought I
syllabus.
told y'all that earlier, but I may not have. I get
Hope-
y'all mixed up with the other class.
Yeah.
Chapter 4 is continuation of chapter 3.
Okay, so just don't worry about it at all.
Don't worry about it right now. No. You do what I do. And for some reason, my computer is running like very slow. Let me get out of this and just get out of, oh, I know why. Let me get out of there. That's why. Well, let me just go ahead and show you. I've got 2 or 3 things pulled up. There we go. Now let me pull up. There we go. And open. There we go. And that's what we're doing. We're finding the area under a curve or above a curve. And it includes rectangles. It includes triangles. It includes curves. And it includes shapes that we don't really, polygon or whatever. But we're not using algebra. We're not going back here and going, okay, well, there's 2 times 3, that's 6 square units. And then you got 1, 2, 3, well, 1, 2, and almost 3, but we're going to just do it with calculus and just do that. And then over here, we're going to include a curve, and we're going to get this rectangular, and we're going to do this curve, and we're not going to use algebra. We're going to use calculus. And here, of course, is that, and you can go the opposite direction, depending on what you want to do. Now, most of us read from left to right, so I really don't know why you would want to go from right to left, unless you just wanted to do things different. And it doesn't matter, area is area, so it doesn't matter which way you go. All right? Now, let's talk about what is integration. As I said, when we were doing derivatives, you took the algebra with the difference quotient, you put the limit as h approaches 0, and you had calculus, and it was called the derivative. Here, we're going to skip this part because I'm not going to, basically they're showing you do the algebra or do the calculus, which is easier. The calculus is easier. That's what they're showing you with doing these two. So I showed you here. I'm not going to do the same thing over and show you here and here. So I'm going to skip this part, and we're going to go straight to the antiderivative or the integration. Speaking of antiderivative or integration, they can be used simultaneously. Integration is the process. The antiderivative is the product of that process. You will have people use them interchangeably, okay? There are some instructors that will have a conniption if you say antiderivative, or if you say integral, or if you say both of them. I don't know. I don't keep up with that stuff, okay? But they are used in this unit a lot. You have, these are called integrals. These right here are called integrals. There's 2 types of integration, or 2 types of integrals. There's definite and indefinite. An indefinite is usually based on theory, and there's not much application with an indefinite integral. So there's not real world applications with an indefinite integral. Definite is when you have practical application with real world problems. And a lot of you say, well, what's the real world problems? Oh my gosh, there's all kinds, because right here, I'm fixing to show you. Let me get out of this. This is your goal, chapter 6. Well, there's your goal right there. Chapter 6. You're finding the area between two curves. Now, some of y'all may think this is a Star Trek emblem. All right. But you can apply this to mechanical engineering. You can apply it to civil engineering. You can apply it to architecture or land surveying. You could apply it to ceramics. You can apply it to physics with a 3D. I mean, you apply 3D to this, and you've got all kinds of applications. So we won't go there, okay? This is what we're heading toward, chapter 6. I can bet you a bottom dollar, the way that I will test you on chapter 5 is put a bunch of these on chapter 5, 6 test. Because if you can do these, you can do chapter 5, okay? So look for a lot of these on the chapter 5, 6 test. Because I give you 10 of these, I don't have to give you a single one on chapter 5, because if you can do 10 of these, you can do chapter 5. All right, so that's where you're heading. So you got to know which one's definite and which one's infinite. A definite integral has parameters. From 0 to 6, that's your parameters. That is the difference between a definite and an indefinite. Indefinite does not have parameters. They're set up the same way. You got your height, which is your function. You got your width, which is dx. Height is your function. Base is dx. So they're set up the same, except a definite has A and B right here, parameters. Indefinite does not. And I sent y'all a handout. And there is your handout. That is something that you should be printing out and bringing to class tomorrow. We're going to be starting with this one right here, the power rule. And we're going to start right now with a couple of examples. Start off with something simple. F of x. Well, let me show you how they're going to be written. You're not going to have like you had a derivative. F of x is equal to x squared, and then you go down here and you do f prime of x is equal to 2x. Oh, sorry. 2x. That's not the way they're going to be written. They're going to be written like you see up here. All right? If they want you to take the derivative of something, I mean the antiderivative, they're going to put the s here, and they're going to say x squared dx. And then if it doesn't have numbers here, that means it's an indefinite integral. So this is how you do the power rule, which is right up here. Power rule says that I'm going to take that x squared and I'm going to add 1 to it and put 2 plus 1 down here And then I'm going to add a c to it. And that right there is the power rule. Real simple. Whatever you got right here is going to go in the denominator. Real simple. Why is the c there? Well, let's go back to derivatives. Let's go back to chapter 3. Let's visit chapter 3. Let's go back here and review chapter 3, which is derivatives. And I'm going to give you f of x is equal to 3x squared minus 21. And f of x is equal to 3x squared plus 100. And f of x is equal to 3x squared minus 1/2. All right, somebody give me the derivative of the first function.
6x.
Good job.
It's
And
6x
somebody
for
give
all
me
of
the
them.
derivative of the second function.
6x.
And third function?
Six.
Well, you got 3 different equations here, and the antiderivative is what? Or the derivative is what? The same. So when you take the antiderivative, you have to make up for whatever's in that function that you don't see, and that's what the C is for. Now, somebody tell me that's had a calculus class or a pre-calculus class on a test, how important is that C?
If you don't have it, you get a 0.
If you don't have it, you get the whole problem wrong. So this is not, oh, well, no. It's not for discussion. If you don't put that C, there are some teachers, especially that teach Calc 2, that will mark it wrong. And you can cry and bring bulldozer mom and helicopter dad and get a meeting with the department head, and it's not going to do you a damn bit of good. So you might as well learn to do it. Okay? The C is to make up for what you don't see in the function. So this says this belongs to the x cubed over 3 family. That's what that means. Okay? This right here, x cubed over 3 plus c, means that the antiderivative you just did belongs to the x cubed over 3 family, because you don't know what this guy could be. Everybody with me? You don't know what the rest of the function is. And on a definite or an indefinite integral, and I hope I spell this right, on an indefinite integral, you have to put C. You have to. Now, what about other properties with the derivatives? Well, that's a good thing. Let me get my red pen out, or a red pen. I have got to go to Walgreens and get me some more red pens. Oh, crap. Can you pull a constant? Yes. Just like you did with derivatives, you can pull a constant out. That's not illegal. What about rewriting? Yes. You need to rewrite because you're going to have radicals. And radicals and calculus don't mix. And what about product sum rule? Yes. You can use the product sum rule and do each part of the sentence separately. So you can still use those same things that you used with derivatives, only with antiderivatives. Let's do another one. Let's do another example. That's your first example. X cubed over 3. That's your answer right there. X cubed over 3 plus C. All right, here is one that you can do product sum. Antiderivative of x squared plus 2x minus 3 dx. Now, with this one, you can use your rules that you learned with derivatives. Well, this is x to the first, and this is x to the 0. Remember me showing y'all to use those to help you out? Well, same thing with antiderivatives. They'll help you out. And I'm going to pull this 2 out, and I'm going to separate these into 3 separate antiderivatives. So there's a 1 right there, so I can pull that out. 1 x squared dx plus 2 x to the first dx minus 3 x to the 0 dx. And now I can apply the power rule. 1 times x to the third over 3 plus 2 times x to the second over 2 minus 3 times x to the first over 1 plus c. And this is x cubed over 3 plus x squared minus 3x plus c. And of course, I didn't have to do each one of these steps. I'm showing the person that has never seen antiderivatives before. And I pulled out that 1, that 2, and that negative 3, and that left me with x squared, x to the first, and x to the 0. And then I took the derivative using the power rule, the antiderivative of each one, and that's it.
Can you do that third row one more time real quick?
This one right here.
Yes.
1 times x to the third over 3 is x to the third over 3. The 2's cancel right here and leaves you with x squared. And then 3 times x over 1 is 3x.
Where does x to the third over 3 come from?
Right here,
Yes, sir.
the product rule, which is what I showed you
Oh.
right here,
Okay. I got you.
right there. So I will add that. Since you asked that, I'm going to add it. And I'm going to do that in orange. Plus 1 over 2 plus 1. Plus 1 over 1 plus 1. Plus 1 over 0 plus 1. How's that? That make it a little bit better?
Yes, thank you.
Mr. Parrish, you know I'll try to discourage you as much as possible.
Keep it up. Keep it up.
All right. That's all right. You can do all this homework in 12 hours. So just wait until right before the test to start on it, okay? It's only 6 sections, so it'll only take you half of 24 hours, which is 12. Yes, I'm being a smart ass. Yes, I am. Because some of y'all deserve it. I'm sorry. I'm sorry. I'm sorry. I need to take a pill. All right, so let's do something else. Let's do a definite. How about the antiderivative of x squared dx from 0 to 9? Okay, now we're doing basically, it looks like this. I'm going to exaggerate it a little bit. It doesn't look like that, but I'm exaggerating it so I can show you what we're actually finding. 0 is right here, and 9 is right here. This is a definite integral, and we are finding the area under the curve from 0 to what?
9.
From 0 to 9. So we're finding that area right there. So this is how you do it. First of all, you do your antiderivative. So that's going to be x to the 2 plus 1 over 2 plus 1. And that's going to be x to the third over 3. Evaluated at 0 and 9. Now let's talk about this. What does the word evaluate mean? If you had me for algebra in the past, evaluate and determine means what in algebra? Plug and what?
Chug.
Plug and chug. So this right here, this big long line means evaluate, but it also means subtract. Not only does it mean evaluate, but it also means subtract. Evaluate equals plug and chug, and it also means subtract. Now we're going to do this on a separate page, but that's what that means. This is your upper value, so I'll use green because that means it's the upper value. So that's what you're going to subtract from. And this is your lower value, since red means under, that's what you're going to subtract. So we're going to take this right here over to the next page, and we're going to actually do it. So x to the third over 3 evaluated at 0 and 9. So that means I've got to redo my function with a big set of parentheses. And I've got to subtract function with a big set of parentheses. And since this is green, that one goes there. And since this one is pink, it goes right there. And this means subtraction. Why do we love 0?
Because it's easy to evaluate.
Because it's easy to calculate, and what does it always do to a term? Takes it out. So that goes to 0. So we just got to do this right here, and that's our answer. So 9 times 9 times 9 over 3. Well, wait a minute. I can take that 3 and cancel out right there. And I've got 3 times 81, which is 243. Somebody check my math.
Yep.
Correct.
243 square what? Units. So the area under this curve is 243 square what? Units. And y'all just learned something, didn't you? I'm going to tell you, there are some teachers that will teach you how to do integrals and definite and infinite, and they will lobotomize you. I don't know how. You know how? Because they don't have highlighters like I do. All right, let's do a nerd. Mr. Michelle is looking at this like this is the Antichrist or something. All right, let's do a nerd.
Because it is.
Okay.
But where does the dx go?
And once you take the derivative, it goes away. Okay? Because you are finding the area. This right here, and that's a good question, Mr. Paris. You're still going to fail the class. But the whole part of this right here, this whole thing right here is find the area. Okay? That's my daughter. She knows I'm teaching. I don't know why. She thinks it's 3 o'clock. Find the area. This right here, what are we actually doing? This is calculating the area. This tells me to find the area. This tells me that I'm calculating the area. So once I'm calculating the area, do I need you to stand over me telling me to find the area? No. So think of this, Mr. Paris. Think of that dx as telling you to find the area. And then once you do this step right here and this step, you're actually doing what? You're calculating it. So think of this as directions. And once you start calculating it, you don't need the directions anymore. Does that help?
It does, yeah.
Okay. So let's do a nerd. Well, I text my daughter and find out what's wrong, because usually she calls me when she wants money or something's wrong. So let's go from 0 to 6 of 2x squared plus 3x. I'm just going to stop there. Dx. All right, I'm going to let y'all do that. And I'm going to find out what she needs. I say, you know you're redneck when your daughter sees 2 sheriff cars go by and she calls you to see if you're okay. So she lives near her mother up there on the highway, and she saw 2 deputies' cars with blue lights, which is unusual, go by out here. Because we don't have any crime rate out here. Y'all know why we don't have any crime rate?
Because you get
They'll
guns.
shoot your ass if you break into our house. Because we got guns and we are racist. Yeah. What is it? Racist or terrorist? One of the two. If you got guns. If you're an NRA member, you're a racist or terrorist. I get them all mixed up. This cancel culture, I get everything so mixed up. What is it when you eat yourself to death with a fork? What is that called? Or what is it when you drink too much alcohol, get behind a car and run into somebody and kill them? What's that?
Vehicular manslaughter.
Oh my gosh. What's that? Is that terrorism? Oh, I'm sorry. I'm comparing a gun to a vehicle, you know, and that's not the same thing. Because guns kill people, cars don't. All right. Some of y'all are thinking, y'all are going, what the hell is he talking about? Forget it. Just forget it. All right. I'm just being a smart ass today. I guess the 24 hours doing 11, it's just got me in a smart ass mood. Excuse me, I will try to take a smart ass pill tomorrow to try to deter my smart aleckiness. All right, so here we go. I'm going to do this for those that need the baby step in the middle. 2x 2 plus 1 over 2 plus 1 plus 3x to the 1 plus 1 over 1 plus 1. Evaluated at 0 and 6. All right? So that's going to be 2x to the third over 3 plus 3x squared over what? 2 evaluated at 6 and 0. Well, this guy, A is 2. Somebody tell me what kind of parabola this is. What kind of parabola is this that has a 2? Is it skinny or is it wide?
Would it be
skinny, Hubert? That's right, class.
Channel.
Y'all suck, class. And 0 to 6, let's say this is 6. I got a question for you. Is this area going to be more or less than this area?
Less.
Probably going to be less. Why? Because this 2 has made this parabola skinnier than a regular parabola. And we're only going from 0 to 6 here. And here we went from 0 to 9. So chances are this area right here is going to be a little bit less. Probably a whole lot less. But I'm going to take out my handy dandy yellow highlighter. All right, so let's do it. So 2 parentheses to the third over 3 plus 3 parentheses squared over 2 bracket minus bracket 2 parentheses cubed over 3 plus 3 parentheses squared over 2. Get my highlighter out. What does this mean? What does that blue line mean right there?
Evaluate or subtract.
Subtract, good. And the green is the 6. And the red is the 0. And why do we love 0?
Because it's easy.
Because it takes out everything. Is that always going to be 0? No. We're going to get into that later. So all y'all got to do is this right here. So that's going to be 6 times 6 is 36. 216. Somebody check me. What's 6 to the third?
Yeah, 216.
Plus 3 times 36 over 2. And I know I'm running out of time and some of y'all are convulsing, but you'll be okay. 2 times 216 over 3 times 3 over 3 times 36 over 2. Common denominator is 6. Wait a minute.
That's plus.
No, yeah, plus. Common denominator is 6. 3 will go into 6. 2 times 2 times 216. 2 will go into 6. 3 times 3 times 36. And that's going to be 2 times 2 is 4. 4 times 216 plus 9 times 36 over 6. And that's going to be 864. Somebody check my math. Plus 3. Hold on a minute. Give me a second. 324. Somebody check me.
Yep, those are right.
And that's going to be 1188 over 6, which is be 1. And that'll leave 58, which will be 9, which will leave 48. I got 198 square units. Somebody check my math, please.
That's
correct.
right.
Of course it is. That's 198 units. And in the previous problem, we had 243 units. So it is a little bit less than that. Oh my gosh. Y'all got to do calculus. And then y'all got to do basic what?
Arithmetic.
Basic arithmetic. So half of y'all might as well just quit. Because I guarantee you somebody in here is confused why I changed to a 6. I guarantee you somebody's confused about that. You got to have a common denominator to add fractions. And you should feel good about yourself because you have now started integration. It's okay to say integration in it. Isn't that okay? I hope it is. All right. So.
Integration is the devil's word.
Oh, I saw an article today that a man wants to be Filipino. So he's changing his.
Korean.
Is it Korean or Filipino?
Yeah. No, he was like, this is British dude who's some YouTuber or whatever, and he said that he was going to try to, or he's now Korean, and he changed his name, and he's apparently Korean, and
you know what I want to be?
Non-binary or whatever.
I identify as a millionaire.
I know. Somebody get
So
your money.
I would like to define myself as a millionaire. I think everybody's eating Tide Pods. Okay.